Hello everyone, my name is Indra and I have spent the last 10 years working at the Ministry of Transportation, Government of Indonesia. Today I'm going to present my latest paper titled Negative Externalities from Port Development, Evidence from Marine Pollution in Indonesia. Just wait a moment, I'm going to show my slideshow regarding this issue. Okay. As we can see here, the problem that we are trying to resolve is that human activities involving sea transport have been increasing in the recent decades, posing more threats to the sustainability of ocean life. Therefore, understanding the causal relationship between port activities and marine pollution is necessary to conduct for more comprehensive national port planning and accounting for the negative externalities. However, the causal impact of sea transport development on marine pollution are hardly researched. It is still debate whether seaports affect environmental quality, since the effect might work in both directions. Logically, the new sea transportation will increase port source pollution, therefore the negative effect. However, in the long run, a new port may reduce pollution level if it substitutes for other polluting mode of transportation. This is called a rebound effect. The challenge in measuring causal relation is the placement and timing of port development are most likely non-random processes. So the previous study do not clearly show that I know of whether a causal relationship exists between port activities and poor water quality. So what's the objectivity here? So we are trying to examine of a small port on a nearby marine pollution level measured by chlorophyll A concentration in Indonesia. Why do we use Indonesia? As we can see here, Indonesia is a large country, consists of more 17,000 small and big islands, making it highly dependable on sea transportation. So to improve connectivity among islands, the government of Indonesia has intensified the small port development. These dots represent small port location that has been built in the last 10 years. This different color represent the gradual opening process of new small port operation. However, at the same time, to ensure environmental sustainability around the port, the government of Indonesia has imposed a set of regulations. Nevertheless, the environmental monitoring mostly focuses on the large international ports and is less strict for the smaller local ports. If you are wondering how small is the small port that we are talking about is, as we can see here, in the left side is the Belawan port, one of the biggest port in Indonesia, and the right side is the Kawalos port in North Sulawesi. It is located in a small and remote island. We are focusing on the small port in this paper. So to estimate the causal impact of small port operation on marine pollution, we use the gradual opening process of new small port operation in the selected area in Indonesia between 2012 and 2019. We focus on estimating the average treatment effect after the first small port is constructed within 6 kilometers using the difference framework. Small port, I've already explained to you before, are unlikely to be randomly distributed. Some physical specification must be met, which heavily influence the emplacement of selection decision. So And also the timing, so the timing also non-random because it is based on the local government aspiration. So to tackle this issue, we use two sources of variation. First, we compare the change in before or after pollution level in the small pot area with those areas which are still in the planning process. Second, comparing the change in the pollution level at sites whose port enter into operation earlier with those whose port enter into operation later on. So we also control for the different time trend at the provincial level to capture local government aspiration that might partly explain variation in the timing of small port opening. So from this equation, we represent the marine pollution level. So marine pollution level of pixel E, province G at Mount T, and the alpha is our variable of interest, represent the small, the O represents small port operation. So we also include some variable that potentially correlates with the small port operation and pollution level. Since the availability and accuracy is particularly poor in developing countries like Indonesia, we propose a novel dataset by using the moderate resolution imaging spectrodiometer or MODIS that provides global monthly satellite data. So we use monthly georeference panel at the pixel level. We have multiple data sources such as, instead of satellite data, Ministry of Transportation small port planning and development documents and other supporting reference. So in the observation is all pixel within 6 kilometer buffer in marine area from each small port. However, we drop every pixel at a distance greater than 4 kilometers from the coastal line to increase comparability, leaving 480 pixels for our main analysis. So this is our baseline estimate. For the baseline estimate, we include more control in each column to add precision to our estimate. The result, as we can see here, remain comparable. So our preferred model is in the last column with complete control that show the chlorophyll A concentration in sites where a new small port was in operation was 1.7% higher than in sites without small port located nearby during the observation time. However, our estimate is small in magnitude, with 1.7% increases is equivalent to only 7.9% increases in chlorophyll A concentration in the last decade. Such a small addition concentration is also perhaps too insignificant to induce the fish kills associated with eutrophication. The limited cargo throughput in the small port may explain this estimates. However, we further argue that the treatment effect grows as a port gets substantially larger. If this is true, the larger port that will be 100 times larger than the small port may exceed level known to cause chronic eutrophication. Please note that these larger ports are mostly located in the city area that already has high chlorophyll A concentration. The cost could be substantial. We also trying to estimate the distant profile treatment effect, since already explained that we only selected all pixels within 6 kilometer buffer from small port. We further verify this assumption. As we can see here, the y-axis represents the coefficient of chlorophyll A concentration, and the x-axis represents the distance from each pixel to the nearest small port. This is the point estimates with a 95% confidence interval. If the bar does not pass the horizontal line at 0, so the point estimate is statistically significant. As we can see here, the effect is mostly positive and statistically significant, and verify our assumption that beyond 6 kilometers, the effect is diminished. So we also analyze the heterogeneous effect of small port. So as we can see here, the darker side is represent the higher chlorophyll A concentration. It is concentrated cluster in the eastern part of Indonesia. So since almost 81% of small port clustered in the eastern region, the eastern region experienced more relative adverse effect from the small port than the western region. Yudhistira and Sofiandi confirms the result, in which eastern region seems to rely heavily on local ports rather than the larger ports. So, and how about the port characteristic? Is the result might be different due to port characteristic? Our in the first and the second column represent that the distance between port to the nearest city. So our results show that thus the port located nearer to the city show relatively higher chlorophyll A concentration. Our results show the opposite. The chlorophyll A concentration tend to be higher to the port that located farther away from the central district. Why? One explanation is probably due to the environmental monitoring process. In remote or small islands where the small ports are located, that can be more expensive. And how about the jetty size? As we can see here in the last two columns represent that there is a possibility that the jetty line may be a good predictor of chlorophyll A concentration, since a longer jetty lane can host a larger vessel and accommodate more port activities. And then we are trying to see whether the effect of small port on chlorophyll A concentration may magnify or even diminish over time. And then we're trying to estimate the dynamic impact of the small port, decomposing the treatment effect months before and after the operation of small port. As we can see here, the effect is mostly concentrated in the 2-month period of the opening of small port. This temporary effect might be the result of self-purification of the marine ecosystem process. Since we use the DID, different in different framework, we're trying to see if this is between the control and the treatment group have a parallel trend, since the parallel trend is the basic assumption of difference in different framework. We are trying to see the anticipation effect. So we're trying to see the anticipation effect. We found the short-term anticipation response amount before the small port opening that might be associated with the construction activities. However, we believe our estimation strategy is not affected by this anticipation effect. Therefore, our difference in different strategy remain reliable. We also check for the port and different pollution outcome. Column 1 to 6 represent the marine pollution, and 7 to 9 represent the air pollution. However, we found no effect on between small port and air pollution. So the conclusion is our refined satellite data to overcome limited data on marine pollution level and a staggered difference in different strategy is chlorophyll concentration increases 1.7% after the small port begins operation within 6 kilometer distance from the port. The effect attenuates with distance and disappears beyond 6 kilometers. And then the effect seems to be concentrated in the short 2-month period after the small port begins to operate. And the effect is also geographically concentrated in the eastern part of Indonesia. The small port increases other marine pollution measurement besides chlorophyll A concentration, but we found no impact on air pollution. So we suggest for the research to check the effect for larger port and then how to compensate households or communities who live in or making a living near the affected area. This is the end of my presentation. Thank you for your kind attention.